Yo guys, what's up? This is Ethan coming back at you again with another Intro to Pi episode. Let's get into it. Today we're doing some variables, we're doing some basic data types. So I've just gone ahead and opened up the command prompt, made the text a bit bigger, and we're in the Python read eval print loop. And basically you just type Python, puts you in this nice loop, and you can just type anything, and then whatever you type out is going to get printed out. Anyway, today we're going to go over variables and basic data types like integers, strings, dictionaries, lists, that type of thing. We're going to start off with variables. So a variable is essentially a container which lets you store something a bit more permanently. So for instance, we had print hello world last time. I showed you how to print hello world. Now what if we wanted to use hello world somewhere else? We have to type out hello world again and type it out again. Well, you know, not much fun for me. So what we're going to do is we're going to go and make a variable. So we're going to go text is equal to hello world. Now you'll notice it didn't print it out this time because this prints it out if the item you're doing is like a printable or it's not being assigned to something. So here we're assigning it to text, so it's not printing it out. We're saving it in. Anyway, so the way the assignments basically work is anything on the left hand side is considered a name of a variable. So this can be quite literally anything, but you know, you should generally keep it to the alphabet. You know, you can put some numbers in there if you want, like hello 1, except we have to define it as something, and that's generally how you do it. So you could do it whatever you want. It could be called hello, you know, and then if we go hello, you know, it prints out hello. Anyway, that's basically that, but there are some things to consider here. So you've got the name on the left, you've got an equal sign, and then whatever on the right will be saved under the name on the left. So our string hello is going to be saved under this variable hello, and it is important to note that variables are case sensitive. So if I go hello, you'll notice that hello is not defined, but if I go hello with all capitals, it returns a value. So they are case sensitive, so it's something really key to remember. And in Python, the standard is if we're naming something, we put an underscore between it. So if we go your name, you might be thinking your name, someone is even. You might be thinking that's the way to do it. No, you're not quite right. You might be coming from another language where you follow camel case and you got this, and in Python that's also not quite right. So the correct way in Python is to use underscores, and this is called snake case. And so all three of those are valid variable names, but the Pythonic way of doing it is going to be your underscore name. So that's just something to note going forward, is that we're going to try our best to, you know, teach you these good habits, and it's in a document called PEEP8. So PEP8. If you just put that in Google, you'll be able to have a big read through. There's quite a few things in there that you might not understand, but you know, it's just a good starting point, and it helps to keep your code readable and understandable. And then if anyone else picks up your code, you know, they're going to be a bit more familiar with it because it's, you know, something that looks familiar. Anyway, you know, let's dive straight into data types. So data types, we've got some basic data types. You know, you want to represent numbers, we want to represent strings. Strings are just like characters, you know, like words. And then we'll dive into some dictionaries and we'll dive into some lists. Anyway, if we go and say x is equal to 1, that prints out 1. C is equal to 1. That prints out 1. You might be wondering what the difference between the quotation marks here and the non-quotation marks here, because there's none there. Well, it's quite simple. So x in this case is being set to a number. So numbers, you know, are something that you can go 1 plus 2 and that's going to give you 3. Whereas if we go 1 plus 2, that's going to give you 12, because it's combining the strings rather than doing math on that. So basically, anything outside quotation marks, you know, that's going to be a number, a whole number at that as well. Because if we go and use this thing called type, and it's a function. So functions have parentheses, and then within this parenthesis we're going to put x. So it just goes away and it gives us back the type of x. So it's telling us that x is type int. So int just represents a whole number. So if we go x is equal to 1.5 on the other hand and go and look at the type of that, you'll notice it's actually a float now. So float's just standing for a floating point number, or basically it's got a decimal in it. So because we've gone 1.5, it goes I don't know how to represent that as a whole number, so I'm going to use this data type which actually lets me use decimal points. And there's a really simple way of converting between these. So basically we have type int, so x is going to print 1.5, but if we go int and then brackets put x, it's going to convert it from whatever type it is to an integer. And so that's going to give us 1. So that's pretty cool. So you can do that on anything basically. So we could go float x, although it's already a float, so it's okay. And that's just going to convert between types. So if we go x is equal to int x, and then we call type on x, it's now an int. So x is equal to float x, it's now a float. Kinda cool. And now I've got my next favorite one, the one you're going to use a lot. Strings. So strings, you know, they're just words. We represent them by using double quotation marks or single quotation marks, like A or A. You can't mix and match, so you can't go like this. It expects one that starts and one that ends, and it expects them to be both exactly the same. So that's just a key thing to remember as well. You'll get pretty used to just using one. And they're called strings, so if we go A is equal to A, and then we go type of A, it's going to be a string. We can also convert between integers and strings and stuff as well. So if I want to go str x, it'll give us a string representation of that float. Now a key thing to note is, you know, you can't make everything a number. So if we go A, which is a word, a letter A, and we try to convert it to an integer, Python's going to go, you know what, I can't convert that to a number in the base 10 system. And base 10 is just, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. How we represent numbers, computers represent with base 2. You don't need to worry about that later on. But that's basically that. And there's also some more cool things we can do with int. So if we go x is equal to 1.5 again, and then we go round x, you know that it rounds it up. And if we go x is equal to, say, 1.2, and then we go round x, it'll round it down. So that's just another cool thing we can do. There's also dot lower, dot upper. So if we go a dot upper, if I get my calls right, it'll convert it to uppercase. It's cool. You've got upper, you've got lower, you've got capitalize, you've got case fold. So they're just some pretty cool ones that I use in my everyday. Anyway, let's move on to some cooler things. This is all the fundamentals. We're going to jump into lists at the moment. So, you know, currently we've got all these variables. But what happens if I want two numbers? I mean, I can make another variable. You know, go c equals 1, x is 1.2, so you can v can be equal to 2. But, you know, then we have to remember them. And, you know, that's not really good for storing a collection number. So we've got this thing called a list, which we represent with square brackets. We can store numbers, we can store anything in it. And that'll return the list. If I go lst is equal to hello, and then we go world, and then we're going to go into a for loop really quick. So for item in lst print item. So this is going to go through each item in the list and print it out. You know, so it prints it out on new lines, and because print is automatically putting a new line character at the end for you, you'll notice that it prints it out with a new line character. It's pretty cool and useful. But we'll dive into for loops a bit more in a later episode, basically showing you how to do this. And you can also access them by index. Indexes in Python and most programming languages start at 0. So if we start at 0, so we go 0, it'll print out hello. lst1, which you might think is hello, is actually world because we start counting from 0. This is item 0, this is item 1. And another cool thing we can do on lists, we can use dot join. So if we go empty string dot join lst, it joins everything together. And whatever you join in here is what it will join it with. So I want a space, you know, say I want an underscore. Say I want a new line. Backslash n puts a new line in there, by the way. That didn't quite work because we need to print it out for the formatting to work. Because otherwise it returns a representation of said string. But it's just another cool thing you can do on items in a list. And items in a list, you know, can have as many different forms as you want. They don't all have to be the same data type. And another thing we can do, which is pretty cool, is there is a keyword called in. So in lets you check something. So if I want to go and check, is hello in LST? Yes, it is. Is Ethan in LST? No. So that's just pretty cool. You know, it tells you hello, yes, hello is an item in here, and Ethan is not an item in here. You know, something else that's pretty cool. And then we can also change items in the list by going, say, hello, and then I'm going to go equal Ethan, and then there we go. So if we go Ethan in list, Although one thing you need to note, you can't do the index notation on items bigger than the list. If I go list 2, you know, it'll say it's out of range, which means you've put in a number which is bigger than the list itself. And if we try assign that, it'll say it's out of range as well. So the way we do that is we just append. What do we say? Testing. Now if we print out list, you'll see that testing is on the end. And another cool thing we can do is if we want to use extend. So previously we added one item with append. Extend takes in iterable or something it can loop over, and then we'll just go 1, 2, 3, and it'll extend it by that many. And you know, you can contain more advanced data types. We can put dictionaries in lists. So a common use case is you have a list which contains a list of dictionaries, and each dictionary has data within it. But we're going to do the old dictionaries next, so we'll dive into that now. Lists were a cool way of storing data sequentially, i.e. one after the other. So we go, hello Ethan, testing 1, 2, 3. Now we have something called a dictionary. A dictionary is kind of cool because rather than having to loop over the list to find something or yada yada, you can store it with a key, and that key represents a value. It's basically like another set of variables. If we go dictionary 1, and then we put a colon, and then we put a value. So that's 1, 2. So if I go D is equal to dictionary, and then we're going to go key, and then we're going to go value. If I print out D, you know, we can print out the type of it, it'll be a dictionary. And then if we go D, and then in here, go key, it'll print out value. Now we can't index this with a number, because if we index it with a number, it's going to think that that number is a key. So if we go D0, there is no key called 0 in the dictionary. You know, 0 and D is false. But we can go D0 is equal to, press enter, and now it's in the dictionary. So this is our key on the left, separated by semicolon or a colon. And then we've got the value on the right, which is just another cool way of doing it. And then if we go 0 and D, it'll return true, because it returns based on, and then some cool stuff we're going to show you down the line is using for loops and how to use for loops on dictionaries, but we're not going to cover that today because it might get a bit complicated. But basically it'll throw a key error if it doesn't exist, and we're going to go over something really cool later on, which is called a default dict. So that's a dictionary where if a value doesn't exist, it'll set one for you. So say we're using an application to count how much money each person has. You know, if you're trying to add money to someone that doesn't exist, you know, you want to create them with $0. Rather than coding that logic for you, there's a nice dictionary class which will let you automatically start off with a number. So if it raises a key error because it can't find them, then it'll just go, I'm just going to automatically set you to 0, or I'll automatically set you to whatever you tell me you want me to set it to. That's just really cool and something we're going to use later on. Dictionaries can also contain some nice advanced data sets as well. So if we go lst is equal to lst, and then we go d, you'll notice that we've stored our list. And then we can make that way more complex by going d lst is equal to a new list, and then in that we'll have a dictionary which has name, and the name will be Ethan. If we print out d, list and list, dictionary, and I want you to think for about 15 seconds. How do I print out lists? So I'll start it off. If I want to print out my name from the dictionary, from D, what do I type in? I'll give you about 15 seconds to think on that, and then we'll get back to it. I'll just start a timer for you guys, because I genuinely want you to think about it in your head.
Today's video is proudly powered by our partner, Oxide Hosting. Get your products hosted by them with their cheap, reliable services. So what are you waiting for? Check them out in the description below.
That's been a little bit over 10 seconds, but I hope you figured it out by now. So we're going to go D, and then we need to get the list, which is going to be LST, and that's going to give us this list here. Now the list itself, we don't want that. We want the dictionary with the name in it. So that is item 0. And then that's going to return another dictionary, which we can then get the name out of like this, and that's going to print out Ethan. I hope you guys got that, otherwise you can play around with it, you know, and just try some more cool stuff. And then also later on, not this episode, but like later on in the series, we're going to show you how to sort based on values in a dictionary, how to sort lists, and a whole bunch of really cool stuff. Can't wait to show you guys. And finally today, we're going to be covering something called a set. A set is basically a dictionary, except it's unique. Alright, I'll take it back. It's basically a list, except that it's unique, and yeah, that's pretty much it. It's unique. You can't have two of the same data type in a set. Ooh, something else we'll cover really quickly is a tuple. So if we go like this, we type in the type of that, see that's a tuple, and a tuple is essentially something which is a fixed size. If I go y is equal to a tuple, and then in that we'll go 1, 2, 3, 4, 5, we print out y, see it's a tuple. This is basically a list, except we can't change anything in it. So we can't go y is equal to 6, you can't support, it does not support item assignment. So, we can't do that, but it makes it really easy to go like 3 and y, and it's just a way to create a set of objects that won't change, but also grouping them together to save using multiple variables, which is one of the key parts of a collection. And then another cool thing while we're at it, I was going to save this for a later episode, but if you want the length of a list, you can go len and then pass in an iterable. So we can go y 5, we can go len of lst 6. You want to count them out, 1, 2, 3, 4, 5, 6. So yeah, it's cool. It saves making you a for loop and counting it yourself. Anyway, on to sets. Sets are going to be a bit trippy because they're actually defined with these as well. But if we go type of that, you'll notice it's a dictionary. So this is how do we make a set. We actually have to go and physically call set if you want an empty set. And so that's how we make an empty set. But if you're making items with stuff in them, that's okay. We notice if I do this, I'll actually put it in here. You'll see that it's a set. So basically, if you use a comma instead of a colon, it'll think of it as a set. But if you're not defining any values, you'll need to call the set converter on that. And sets are really cool because it makes this lookup really easy. So we're going to go s.add 1, 2, 3, 5, 6. And then this is going to be an instant lookup. So 4 and s. False. You might not notice the difference around small things, but a set is an instant lookup. It'll instantly tell you in one operation, hey, this thing is or isn't in the set. Whereas with a list, if we're checking in, it's O to the n, where n is basically where in the list it is. So it basically goes through and has to check every single item, not exactly what we want. So with a set, it's guaranteed to be unique, and it's really quick to look up and see if things are in it. So we can go in ahead and we can add, notice if I add 2 again, it doesn't add it, because like I said, they're unique. Now we can also go set.remove 2, s.add 2, notice it adds it back in. But something to note is that you can't remove a value that doesn't exist. But that's okay. There is a method for that. So if we go .discard, or it'll silently ignore it. So remove basically goes, hey, this is meant to be in there, take it out. Discard goes, it might be in there, it might not be. If it's not in there, don't worry about it, which is something really cool. And so it's like if I accidentally called discard twice on the same thing, it works perfectly fine. But that's basically it. It's really cool, and that's all we're going to cover in data types today because I'm running a wee bit over time at 21 minutes so far. But I hope you guys have enjoyed this, and I'm actually really hyped making this series. There's a lot of cool things that I want to show you right now, but I got to hold myself back because we're still teaching the variables, we're still teaching you data types, and I don't want to blow your mind too quick. Anyway, I hope you enjoyed, and peace out from Ethan. Until next time.